Picture this. It's November 14th, 2023. You're sitting at NASA headquarters, and a completely terrifying realization suddenly sets in. Voyager 1, which is humanity's most distant emissary, has just gone completely silent. We're talking over 15 billion miles away from Earth, out in the dark, freezing expanse of interstellar space. And the probe, it just stopped sending back anything except this meaningless stream of binary data. Basically, its flight data systems suffered a memory failure. Honestly, it really felt like the end of an era. But, of course, the engineering team totally refused to give up. They launched into this incredibly high-stakes mission to fix a 1970s computer from Earth, literally reallocating code to different parts of the spacecraft's memory on the fly.
The universe is 13.8 billion years old, vast, ancient, and mostly invisible. And somewhere out there are answers to questions that keep scientists awake at night. Welcome to our channel, where we explore the darkest corners of the cosmos, the mysteries, the threats, the unknown. This is space like you've never seen it before.
And the sheer scale of this challenge is just staggering. When these engineers sent a command to try and fix the spacecraft, they couldn't just hit enter and see an immediate result like we do on our laptops. Because Voyager 1 is so mind-bogglingly far away, it takes a full 22.5 hours for a signal, traveling at the speed of light, mind you, just to reach the probe. And then, they had to wait another agonizing 22.5 hours just to hear a response back. So every single attempt to save the spacecraft was this massive 45-hour step into the complete unknown. And what exactly were they trying to fix out there? Well, both Voyager probes actually operate on dual redundant computer systems that possess a total memory of just 69.63 kilobytes. To put that into perspective for you, that is barely enough storage space to hold one single average-sized JPEG photo today. I mean, no way, right? Yet this incredibly limited but highly efficient technology is exactly what has successfully navigated our deepest space mission through the interstellar medium for over 4 decades. It's a pretty stark reminder of just how archaic, yet unbelievably robust these machines are. The Voyager computers execute about 81,000 instructions per second. If you're watching this explainer on a modern smartphone, your device is roughly 7,500 times faster than the computer that's currently exploring the space between the stars. It is an absolute engineering miracle that this vintage hardware has not only survived the harsh radiation of deep space, but actually continues to transmit groundbreaking data back to us, using a radio transmitter that puts out about as much power as a tiny refrigerator light bulb. Section 1. The Grand Planetary Tour, a Rare Celestial Chance. So, to really understand where the Voyagers are right now, we have to look back at how this whole crazy journey began. Back in the late 1970s, NASA seized an incredibly rare celestial opportunity. The gas giants were aligning on one side of our solar system, which is a configuration that only happens once every 175 years. This was the perfect setup for a massive multi-planet slingshot maneuver. The rapid-fire journey kicked off with a launch in 1977. Both probes reached Jupiter by 1979, and they completely revolutionized our understanding of it. They captured the very first detailed images of the Great Red Spot, a centuries-old storm bigger than our entire planet. And they found active volcanoes on Io and cracked ice on Europa. By 1980 and 81, they were at Saturn, unraveling those intricate rings. Then, while Voyager 1 took a different path, Voyager 2 pushed onward, hitting Uranus in 1986 and finally Neptune in 1989. The really crucial point here is how their paths diverged at Saturn. Voyager 1 was deliberately aimed at Saturn's moon Titan because it's a world with a super dense atmosphere they wanted to study. That maneuver acted as a giant gravitational slingshot. It permanently altered Voyager 1's trajectory and whipped it up to over 61,500 kilometers per hour. That literally made it the fastest spacecraft in history. But that slingshot also meant it couldn't visit any other planets. Voyager 2, traveling slightly slower at over 56,300 kilometers per hour, continued its tour and, to this day, remains the only spacecraft to ever visit Uranus and Neptune. Now, before their cameras were permanently shut down to conserve precious power, Voyager 1 gave us one final, truly profound gift. On February 14, 1990, from a staggering distance of 3.72 billion miles away, it turned its lens back toward home. It captured the iconic pale blue dot image. Our entire world, everyone you love, everyone you know, appeared as a tiny speck, just 0.12 pixels in size. It is such a stunning visual reminder of our place in the universe. Section 2. Piercing the solar bubble, leaving the heliosphere. So, for the next decade and a half, the probes just drifted quietly through the dark. But as we entered the 2010s, they woke up to make their most groundbreaking discoveries yet. Let's define exactly what they were breaking through. You and I, we actually live inside a giant cosmic bubble called the heliosphere. It's inflated by the solar wind, which is this constant stream of charged particles blowing outward from our sun. For decades, scientists assumed this solar wind would just sort of gradually fade away into nothingness, but Voyager, it proved them completely wrong. The probes discovered a really sharp physical boundary called the heliopause. The solar wind doesn't just dissipate, it hits a hard border where interstellar space pushes back, creating this chaotic traffic jam of plasma. And this brings us to a major cosmic mystery that completely baffled astrophysicists when Voyager 1 crossed this boundary in 2012, followed by Voyager 2 in 2018. If interstellar space is supposed to be this huge, empty vacuum, why on Earth did the probes detect that the density of plasma actually increased as they left the solar system behind? Let's look at the numbers. Inside our protective heliopause, the plasma density is very low, about 0.002 particles per cubic centimeter. But the exact moment the probe stepped outside, that density jumped up to 0.039. And as they pushed even deeper into interstellar space, it spiked to 0.12. The data collected by the probes showed that out there, interstellar space is filled with a colder, significantly denser plasma that collides forcefully with the hot, less dense solar wind trying to escape our sun. Section 3. The mysterious local void, the local bubble. As we zoom out from our solar bubble, the Voyager data helps us understand an even grander structure. Get this, our entire solar system is actually floating right near the center of a massive, almost empty void stretching 1,000 light-years across. When we look up at the beautiful, dark night sky, speckled with bright stars, we are only able to see it so clearly because we exist inside this cleared-out pocket of space. But how did we get into this massive void in the first place? The origin story of our local bubble is honestly like something out of a sci-fi movie. About 14 million years ago, roughly 15 massive stars died in violent supernova explosions. These explosive shockwaves acted like a giant cosmic snowplow, pushing dense interstellar gas and dust outward, creating a hollowed-out void. Then, about 5 million years ago, as our sun orbited the center of the Milky Way, it just drifted right into the middle of this safe haven. So the takeaway here is that humanity is incredibly lucky. We evolved inside a dust-free bubble that protects us from heavy cosmic debris and gives us a clear window to study the stars. Section 4, Eerie Sounds of Space, Interstellar Humming. Now, as safe as our little pocket of space might be, the deep unknown outside holds some pretty strange anomalies. You've probably heard the old phrase, in space, no one can hear you scream, right? Because sound needs a medium like air to travel through. However, space isn't entirely silent if you have the right instruments. Over 14 billion miles away, Voyager 1's hypersensitive antennas detected a steady 3 kHz hum that lasted for 3 continuous years. By converting electromagnetic plasma waves into audible frequencies, scientists actually heard the humming of interstellar plasma vibrating out in the dark. It's a deeply haunting reminder of the active, humming environment that exists just beyond our planetary shores. And speaking of sounds, both Voyagers carry humanity's ultimate time capsule just in case someone or something finds them. Mounted on their sides are the golden records. These gold-plated copper discs are encoded with the entire story of humanity. They carry 115 photographs, greetings in 55 different languages, the sounds of the Earth, 90 minutes of music, whale songs, and even the brainwave recordings of a human being. It's our absolute ultimate message in a bottle cast into the cosmic ocean. Section 5, The Final Cosmic Journey, The Ultimate Fate. Which brings us to the inevitable conclusion of this mission. What exactly lies ahead for them in the distant future? Sadly, NASA anticipates that around 2025, nearly 50 years after launch, the probes will finally lose the last of their plutonium-generated electrical power, which they need to run their instruments and talk to Earth. Once they go silent for the final time, they'll just become ghost ships. Voyager 1 is currently hurtling toward the constellation Ophiuchus, and in about 38,000 years, it will pass near a star called H+79 3888. Meanwhile, Voyager 2 is heading toward Andromeda, and it's going to pass by the star Ross 248 in roughly 40,000 years. And yet, despite how unfathomably far they've gone, the sheer mind-numbing scale of our solar system really comes into focus here. While the probes have already crossed the heliopause, the true gravitational boundary of our solar system is actually the Oort cloud, this distant, massive sphere of icy comets.
It will take Voyager 1 another 300 years just to reach the inner edge of the Oort cloud, and it will take an astounding 30,000 years to fully traverse it and officially leave our solar system entirely.
So, I want to leave you with this final provocative thought. Tens of thousands of years from now, long after the Earth as we know it has drastically changed, these primitive, beautifully engineered 1970s machines will still be completely intact. They'll still be out there, carrying those golden records and the memory of exactly who we were. Will these tiny, silent probes ultimately become humanity's longest surviving legacy, just drifting endlessly in the dark? It really leaves you in absolute awe of our boundless capacity to explore the universe, doesn't it?
The universe doesn't care about us. It never did. But we care about it. And that is what makes us extraordinary. If this video made you think, hit like, share it, and subscribe to this channel. Because the next mystery is even deeper. Until then, stay curious and keep looking up.